Scientists cut off its leg. 30 days later, the leg was back. Not a scar, not a stump. The leg. Every bone, every muscle, every nerve, every blood vessel, perfectly rebuilt. From nothing. This is the axolotl. And it may be the only animal on Earth that has never learned how to be broken. It lives at the bottom of one lake in the highlands of Mexico, a lake that barely exists anymore. And in that disappearing water lives something that should not be possible. A body that rebuilds itself. A creature that never grows up. And a secret that every surgeon on Earth would give anything to understand. Let's start at the beginning. Every salamander on Earth begins life the same way. An egg, a larva, a transformation. The larva breathes through gills. It lives in water. It is soft, fragile, dependent. Then metamorphosis happens. The gills disappear. Lungs develop. The animal walks onto land. It becomes something different, something harder, something adult. This is what every salamander does, except the axolotl. The axolotl hatches, grows its feathery external gills, 3 on each side of its head, fanning out like a crown of red coral. It develops its flat, wide tail, its 4 short legs, its permanent smile, and then nothing. No metamorphosis, no transformation, no land. The axolotl simply stays. It grows larger, its organs mature. It becomes sexually capable of reproduction, but it never stops looking like a larva. It is an adult in a child's body, forever. Scientists call this neoteny, the retention of juvenile features into adulthood. But neoteny alone does not explain what makes the axolotl impossible. Because here is the connection that took scientists decades to understand. The axolotl can regenerate because it never stopped being a larva. When you were an embryo, before you were born, your cells had one extraordinary ability. They could become anything. A heart cell, a nerve cell, a bone cell, whatever was needed. Then you were born, and those cells made their decision. They became what they became, and they stayed that way. A heart cell cannot decide to become a leg. A nerve cannot decide to become skin. The decision was made. It cannot be unmade. In the axolotl, the decision was never fully made. Its cells remember what they were before they specialized. When a limb is amputated, the cells at the wound site do something that should be impossible. They dedifferentiate. They forget what they were. A muscle cell forgets it is a muscle. A bone cell forgets it is bone. They revert, backward, to something closer to what they were before they ever chose a role. And then they begin again. They multiply. They reorganize. They rebuild the missing structure from the inside out. Bone first, then muscle, then nerves, then skin. Following the original blueprint as if reading instructions that were never lost. Within 30 days, the leg is complete. Not approximately complete. Not mostly complete. The axolotl does not scar. In every other animal, including you, when tissue is damaged, scar tissue forms. It is the body's emergency repair. Fast, functional, permanent. Scar tissue is not the original tissue. It is a patch. It cannot do what the original could do. A scarred nerve cannot conduct signals the way an unscarred nerve can. A scarred muscle cannot contract with the same precision. The axolotl has no patch, only the original. It regenerates its spinal cord. If you sever the spinal cord of a human, the signals from brain to body stop. The glial scar forms immediately, a wall of emergency tissue that prevents further damage, but also prevents any healing. The axolotl's spinal cord does not form a glial scar. The neurons on both sides of the cut extend toward each other. They find each other. They reconnect. Signals flow again. In 2024, researchers discovered something new. When the axolotl's spinal cord is severed, neurons in a completely different part of its brain, far from the injury, activate. They release a neuropeptide that travels to the hypothalamus. The hypothalamus releases hormones, and those hormones trigger the regeneration process in the injured spinal cord. The brain coordinates its own repair from a distance. It regenerates its heart. If you damage the human heart, if muscle dies from a heart attack, that muscle does not come back. Scar tissue replaces it. The heart beats around the damage, weaker, forever. The axolotl's heart muscle grows back. The damaged cells are replaced by new heart muscle cells, not scar cells, that integrate into the existing tissue and beat in synchrony with the rest of the heart, as if nothing happened. It regenerates parts of its brain. In 2023, a team of researchers published findings in the journal Science. They removed portions of the axolotl's cortex, the outer layer of the brain responsible for complex function. The axolotl rebuilt them. Not approximately, not partially. The specific cell types that were lost were replaced by the same specific cell types. The axolotl's brain knew exactly what was missing and rebuilt it precisely. No mammal on Earth can do this. Not a mouse, not a rat, not a chimpanzee, not you. And yet, the axolotl nearly does not exist anymore. It is native to one place, Lake Xochimilco, in the highlands of Mexico City. A lake that once covered more than 2,000 square kilometers. A lake that the Aztec civilization built its capital city upon. Today, Lake Xochimilco is a fraction of what it was. Drained, polluted, invaded by species that were never supposed to be there. The axolotl in the wild is critically endangered. Some surveys have counted fewer than 50 individuals in the entire lake. The animal that can rebuild any part of its body cannot rebuild its home. In laboratories around the world, at Harvard, at the Max Planck Institute, at universities in Vienna and Edinburgh, scientists are studying the axolotl to understand something they have been trying to understand for decades. Why can it do this? And can we learn to do it too? The answers are beginning to emerge. The axolotl's genome is the largest of any animal ever sequenced, 10 times the size of the human genome, 32 billion base pairs. Somewhere in that vast genetic library are the instructions for rebuilding a limb, for regrowing a spine, for repairing a brain. They exist. They are real. They are written in a language we are only beginning to read. The axolotl cannot teach us directly. It has no language. It has no desire to share its secret. It simply lives at the bottom of a disappearing lake and does what it has always done. It gets hurt, and it heals. Completely. Every time. We built hospitals. We trained surgeons. We invented prosthetics and implants and everything we could think of to replace what the body loses. The axolotl never needed any of it. It just needed to remember what it was before it forgot. Nature does not break the rules. It simply has different ones.